Welcome to Visionaryx, our podcast where you can have real and simple conversations with us about various tools and technologies. I'm Grafana, and
I'm Prometheus. In this podcast, we dive into exciting discussions about simple and deep technical topics in the world of DevOps and cloud. You can find the full transcript of this episode on our website, visionaryx.tech, to follow along with us. Stay tuned and enjoy the adventures in the world of technology.
hello to the best monitoring platform in the world.
Oh no, I'm not the best, but I'm one of the good ones.
Well, why are you one of the good ones?
Wow. I came from SoundCloud, and Cloudflare is using me to monitor its infrastructure. Let's forget about that. Are you here for integration again, or do you have something else to do?
Yeah, I have a HTTP GET. I want to connect to your data source.
Come on. You need to connect to my API query and my API query range and my API series and my API labels. Well, now that you're connecting, let's do something smarter. How about using pre-aggregation?
Pre-aggregation, what do you mean exactly?
Look, you always come and get lots of raw data from me. Then you start to work on it and put it together. This makes you and me tired.
Well, yes, but do we have any other way?
Of course we do. I can put the data together for you before. For example, I can work out your hard queries before, using recording rules.
Wow, that's great. So I get the results faster?
Oh my goosh. Yes, and we can use downsampling too. For old data, we keep the hourly average, not the minute details.
Yeah. So the amount of data gets smaller, and I can draw the charts faster.
You got it right. Now when you load your dashboards, they show up in a flash.
I have a question. I know we both work with metrics, but I always wanted to know, for you, as a system that collects and stores, what do metrics mean, and why are they important?
Oh, that's an interesting question. For me, metrics are like the heartbeat of the systems I monitor. They are numbers I collect over time that show how systems are doing. For example, number of HTTP requests, how much CPU is used, how much memory is used, number of errors in the 400 range and 500 range, how fast APIs respond, latency, number of active database connections, how much the disk is used, how much network is used, number of active parts in Kubernetes, how long services take to start, number of good or bad CI/CD jobs, how much storage is used, how often cache is used, hit rate, number of messages waiting in Kafka or RabbitMQ, how long database queries take, how many logs come in and go out, number of running containers, how much GPU is used in ML work, how long backups take, how many API requests are slowed down, and many more things.
That's interesting. So I collect these numbers and you show them in different ways. Can you tell me which numbers are more important for a DevOps engineer?
Of course. From my experience, these numbers are usually very important. How fast services respond, how much the system uses things like CPU and memory, how many requests come in a unit of time, how the disk and network are doing, and error rate, and also metrics that are special for each app.
Wow, this list is very full. Now I see why DevOps engineers need us so much. By the way, how do you handle all these metrics without your system stopping work?
Well, I use some key ways. First, my database is time series, so I can keep time data in a very small space. This means I can store lots of data using little space. I use TSDB, which makes data very small, like only keeping changes, not every bit. I keep data in 2-hour blocks and have a good system to find things fast. This lets me work with millions of bits every second. And I have a good indexing system that makes getting data faster.
Wait a moment. What does series and time series mean exactly? Can you give an example so I can understand better?
Sure. Look, A series in time series is like a string of data points collected over time. Let me give an example. Let's say we're measuring a server's CPU usage. Every 15 seconds, we write down a number that shows how much of the CPU is being used. These numbers, with the exact time they were written, make a series. For example, 10 hours 0 minutes 0 seconds, 45%, 10 hours 0 minutes 15 seconds, 47%, 10 hours 0 minutes 30 seconds, 46%, 10 hours 0 minutes 45 seconds, 50%. This is a CPU usage series. If you look closely, you can see it's like key value. The key is the timestamp and the value is the CPU use percent. This setup lets us keep and find data in a good way.
Oh, that's interesting. For me, these series are like colors on a painter's brush. When I get this data from you, I do some important work first. For example, I put the data in order by time. I fill in any gaps in the data. I do maths or stats on it, like finding the average or adding up. Sometimes I need to change the units. This is like mixing colors before painting. After this step, I turn this worked on data into visual displays that make sense for users. For example, the CPU usage you talked about. I turn it into a line chart that shows how the system worked over time. I don't just see numbers. I see patterns and trends. I can show this CPU usage next to the number of HTTP requests. This way, we can see if more traffic makes the CPU work harder. My job is to turn these raw numbers into something that means something to a DevOps engineer or system manager. They can use this to make decisions.
Exactly. Now let me tell you about another thing I can do. I have something called Remote Read-Write API. This means I can talk to outside storage systems. So I can send my data to an outside storage system. For example, I can move older data to a bigger database to free up my own space.
Wow, this is very useful. So I can show historical data too, even if you have stored them in another system.
Exactly. Then, if needed, I read and use data I sent to the outside system before. This way, I can keep a lot of historical data without making my main systems slow. I can work with special storage systems like Influx or Thanos too. I manage my data on a big scale and still keep things fast and working well.
Prometheus, you were talking about time series just a few minutes ago. Can you explain more about how you keep data? I mean the behind-the-scenes tech details.
Of course. As I said, I use TSDB. Now let me tell you more about the details. I keep data in 2-hour blocks. Each block has a few parts. 1. An index file that keeps series metadata. 2. Many chunk files that store the real data. 3. A tombstone file that shows deleted series. I use advanced squeezing methods. For example, if a metric stays the same for a while, I only store the changes, not every data point.
Wow, that's very interesting. So when I run a query, what exactly happens?
Well, when a query comes, I first look at the index to find related series. Then, using a good indexing system, I quickly get to the right chunks. If the query has complex operations like rate or sum, I do these calculations on the raw data. To make this process better, I use tricks like lazy loading. This means I only load data that I really need.
This is really complex. How can I use this structure to display data better?
Well, you can use this structure to make your queries better. For example, if you're drawing a time chart, you can use a step parameter that matches my chunk size. This lets me give you data faster. Also, you can use my recording rules. These are queries worked out before, which can make dashboards load much faster. Thank you for listening to Visionaryx. You can find more technical and practical discussions on our website visionaryx.tech.
Thank you for listening to Visionaryx. You can find more technical and practical discussions on our website, visionaryx.tech. Next time, we'll be talking about reproducibility. Goodbye for now.
Goodbye.